Um, because, during COVID, we learned some things, right? So we learned how to get really good at, um, you know, holding class or office hours virtually and, recording lectures and things like that. So I started recording all my lectures, which makes it really nice for people who, this is an in-person class. I mean, if you say, ooh, she's recording, ooh, I could just join the link from my dorm room and lay there in my pajamas and take the class. This is definitely, an in-person class. You're not supposed to, be joining virtually unless it's necessary, okay? But the nice thing about that is, the way that it works well is if people, you're not feeling good. I mean, even though COVID's sort of behind us, people are a little more uptight, I would say, than they once were about, being around people who are coughing and sneezing. And your dorm rooms will become, or your dormitories become just a cauldron of germs brewing, right? Because us upstate people mix our germs with you downstate people, and college students are always sick, right? Because you're getting exposed to new people and new germs and new viruses that you don't have immunity to yet, okay? When you're combined with people from all across the state. So college students are notoriously sick a lot. So, that's the perfect thing then if you're not feeling well, you are welcome to, I haven't quite worked out the best way to share the link and things like that. I'm still working out the kinks through Brightspace, but there will be the option to join class virtually on a day like that. Or, other things, if you have a family wedding and you had to go home early, but Friday morning, the festivities haven't started yet and you log into class virtually, right? Things like that. Like I once had someone on a swim meet, they traveled down to Virginia, but they were able to get on the Zoom in the morning. They hadn't started their competition and still attend class. So that's the ideal way to use, or I'm still calling it Zoom, it's now called Teams. So anyway, so going over the syllabus, looking at the syllabus first. Actually, no, the very first thing I want to do is I always pass around a piece of paper where I ask you to write out your full name. So I'm going to go in on NightWeb and I'm going to compare who the names written here to the class roster. So write your full name, but then if you go by something else, okay? So if you're Jonathan and you go by Johnny, or you're Catherine and you go by Kate, just put in parentheses what you would like to be called, okay? And also, if you have a difficult to pronounce first name, if you wanted to write me a phonetic spelling, that would be great. If your last name is difficult to pronounce, I try to learn first names and not last names. Okay. So, if your last name's one of those really difficult ones, then don't worry about it. So I'm going to send this stack around and let it circulate. And so I don't want to spend the whole time. First of all, I'm always excited to kind of dive into the fun stuff. So you got an announcement from me, and I thought, oh, for heaven's sake, the word please was spelled wrong, right? I'm like, oh, how embarrassing. The first announcement I sent them, the word please was spelled. Like, how did I not see that? But you got an announcement saying, please bring your graphing calculator today, or, have a device where you could go on to Dad's phones. So we are going to get into some of the fun stuff today. So I always do the syllabus in 2 parts. Because I'll do a little bit of syllabus information today, and then we'll do some math. And then Wednesday, I'll finish the syllabus information and then, do it that way. Because first of all, I throw so many details at you at once. Like I have an education specialist, that's my specialty at Geneseo is math education. So I teach a lot of sections of math concepts for elementary ed. I teach the method course that teaches the math teachers how to go out and be teachers. And normally I supervise student teachers. The sad thing this semester is I'm not supervising student teachers, and the reason is because there were not enough of them. So if any of you are sitting in here thinking would math teacher be a possible path for me? I think we're going to have a shortage. First of all, we have a shortage in students wanting to study math. Students don't want to take math anymore. I blame the high school curriculum. Don't even get me started on that tangent, but high school curriculum took a lot of the cool stuff that used to be in it and replaced it with a lot of stupid crap, right? I don't, that's my feeling as being in the secondary schools quite a lot and seeing what's going on. And I'm like, where did logic go? Where did combinatorics go? We used to do some cool stuff, and why are we doing this stuff instead? So anyway, like enrollment in math is down across our campus and probably, across all campuses. We also, it's a one thing I always try to work on every semester because I hate this. And no matter how hard I try to work on this, Calculus 1 has about 33% of 1 in 3, we call it the DEW rate, where somebody either gets a D, an E, or withdraws. Okay, so that's about 1 in every 3 students, and I hate that, right? I hate that. One of the main reasons, I mean, really, calculus, and this might sound funny too, but calculus itself is actually not that hard. The concepts of calculus are actually very common sense. The problem though is if you don't come in with the prerequisite skills, then you're not going to be successful. Okay, so has everyone seen, because again, Brightspace is new, has everyone seen the module? And I did send you an announcement like 2 weeks before summer ended about the basic skills optional, right? Has everybody seen that on Brightspace? Okay, so again, it's probably, honestly though, some of you I think would be surprised, like especially some of those fractions of like x over 8 divided by 2, like it would not surprise me at all if, people needed practice with stuff like that, okay? But you are going to have to, when we take a test, half of it is calculator on, half of it is calculator off, okay? That's because if you have some of the more advanced calculators, which are called, they have what's called a computer algebra system, okay? So if you have a TI Inspire, but it's not the $30 Inspire, it's like the $120 Inspire, or you have a TI 39. Those have the capability to do all of the calculus operations that I'm trying to get you to do by hand. Once we do more application stuff though, then if it's an application, I'm like, well, use your calculator, right? For the plugging and chugging. But we do want to learn to do basic calculus techniques by hand without a calculator. So you are going to have to do, and I try not to make the algebra and the arithmetic crazy or anything on a test, but you are going to have to do things like -3 minus 4, right? -3 minus 4. How often do I see that as 1, right? I've lost 3. I take 4 more away. It's -7. Okay, so I do see some of even at this level, people making mistakes like that. One of the mistakes that makes me cringe, which is why in the fractions sheet, you'll see the whole first section of the fractions sheet is add 1 to this fraction and subtract 1 from this fraction, because there is a couple crucial calculus operations where adding and subtracting 1 are very critical. And so what makes me feel very upset, and these are the students that are in the 1/3 DEW, but if I tell a student add 1 to that fraction, then they say 4/5, right? That worries me, right? So add 1, 5 over 5. So again, if you were thinking that's 4/5, if you add 1 to it, then definitely go in and work on those remediation skills. Another thing that we learned during the pandemic, again, is just making lesson videos. And so at this point, I have a pretty good collection, because it's been several years since the pandemic. So I have a pretty good collection of videos where I'm just going over the problem. So you'll notice, and once I get into Brightspace, I'll show you, where the links are and stuff, that if you do one of those remediation worksheets, because there's a couple other remediation sheets that I'm going to assign for tonight. If you do those and you have any trouble, there's a video of me going over it. But that way, if you do it and you're fine, then skip the video, right? So I feel like that's a really good way to in education, we call it differentiated instruction. Okay, so if you I don't need this review, you don't have to, right? But then you guys who do need the review, there's supports there for you. So anyway, so my office hours, I try to make them at different times during the day in case, you've got different schedules. So, I have an early morning, I have a late afternoon. My Tuesday office hour might swing around a little bit and maybe end up sometimes on a Thursday. But actually tomorrow I will not be available from 1:30 to 2:30. Okay, so usually people don't meet office hours the first couple of days, but anyways, if you want to talk to me, send me an email, but this office hour tomorrow, will not be held. So anyways, you needed the requirement and the department secretary, I think, checked everybody's transcripts. So we should have not let anybody fall through the cracks where you have to have an 85 college credit or 85 average in pre-calculus for a prerequisite for this class. And again, if you have any doubts, if you're doubts, because even if you took pre-calc in high school and you did terrible in it, you could retake pre-calc, right? And honestly, it would be smarter. Like math, I think it's better to start a little low than a little too high. So if you took pre-calc in high school and did terrible, I would rather you go back to pre-calc in the spring, take calculus, because otherwise what I'd be afraid of is you'd fail this semester, you'd fail because you don't have the background knowledge. And how are you going to get the background knowledge? You'll go next semester to retake Calc 1. And if you still don't have that background knowledge, you might still not be successful on your second attempt. Okay, so you've got to build that foundation first and then go from there. So if you have any doubts about if you're in the right place, I'm happy to talk with you about that individually. So the textbook, this has become a wonderful thing, I think. There was a point where we were required to make students buy textbooks. And I hated that because then I had to follow the textbook because I'm like, well, I made them use all pay all this money, I have to follow textbook. I don't like to follow textbook. I like to do my own thing. I actually think a lot of times the things that I do are better than the things I see in the textbook. Or I can also pick and choose. I like this textbook for this, I like this textbook for this. So I have made, at this point, I have almost all my own materials that we worked from. But there is a free downloadable text, and there will be times when I suggest some pages to read or give you an assignment from that free text. Now, because I'm not making you buy a textbook, I'm also not making you buy a calculator. So whatever calculator you came from high school with, which is probably a TI-84, right? Raise your hand if you have a TI-84. Okay, raise your hand if you have the Inspire that solves equations and does all that for you. Yeah, so that's not quite as common. Or you have a $30 Inspire. What else do people have who didn't raise their hand? Right? If you're going to buy a calculator, especially if you're going to take more math. If you're not going to take more math, then buy whichever model you want. But this, if you're a math major or a physics major where you have lots of math in your future, you would want to buy the TI Inspire, again, the 150 version, not the $30 version. Okay, so that it has a computer algebra system. But any model will be sufficient for my class. One thing that I've noticed though is more and more goes online. I feel like students have a harder time staying organized. Now I see lots of people who have those, which I don't mean to point you out, but you're writing your notes on your tablet and then you can save it all, and it's all nice and organized online. I see a lot of students doing that. Because you should definitely really think of how you're going to organize, because what's going to happen is you're going to have a handout that we're working from that I'm going to tell you to either print or view it online. And then you're going to also have some class notes, right? So you'll be looking at these class notes, but then they went with this handout, or you'll be looking at problems you've completed in class, but if you didn't print the sheet that went with it, you might not know what was the problem that I did all this work for in my notes. And then if you've got just a whole bunch of pages of some notes and handouts and all over the place, then it's hard to stay organized. So I really suggest that you give it a good thought. again, I mean, I'm old fashioned. I grew up in the 80s, so I'm a totally different generation than you guys. So the old fashioned way to be organized was like a 3-ring binder. I have a hole punch and stapler in the pouch that I carry around with me to class. If you hole punch, and then that way your notes are on loose leaf paper, and you've got like, here's the notes we took. Okay, here's the handout that went with it, right? And you had it all nice and organized day by day, right? I think that's sort of how I organize. My calculus is all in a binder upstairs, right? And then I pull out the pages as we're ready for them in class. So I would really think about how you're gonna stay organized. Okay, so finding what you need on Brightspace. So I'm gonna take you into Brightspace in a few minutes and talk a little bit about Brightspace. So the other things that are on the syllabus that is required by the college is the course objectives, okay? So if you read the course objectives right now, they don't mean anything to you, right? Fundamental theorem of calculus, derivative, integral, what does that mean, okay? But what this is, you should be able to, at the end of the semester, read the syllabus and say, yes, this is what we did in this class. Okay, so this is a college requirement that we list on our syllabus what is supposed to be covered. And like I said, I'm not going to talk about the syllabus for too long, but I'm going to talk about the first part of your grade because we are going to start with some of the participation assignments today. Right? So 12% of your grade, which actually, if you look, I mean, quizzes altogether are 15% of your grade. Participation is 12. That should be the category that you can easily get 100 in. Right? So that should really help your grade. So the participation part of your grade, a couple different things go in this category, but I like to, often in class, I will, and especially in these long blocks, right? When we're in the hour 15 blocks, I'll start to see people's eyes glaze over at about the hour point, and I'll say, okay, they need to just sit and work on something. I cannot talk with them anymore. So at least, well, we meet 3 days a week. I'd say at least 1 day a week, maybe even 2. I do what I call classwork, where I put you in a group, I give you a problem. Maybe I ask you to try to figure something out, right? So maybe it's like a problem solving exercise, or maybe it's just practice, right? We learn a lot of techniques where just do some practice on the types of computations that we just learned. But I call that classwork, and you get a 5 out of 5 just for being here. Okay, even if your group turns in a paper that's wrong. Okay, and I'll make notes on the paper. Like I'll look at it. It helps me have feedback too. Like I'll notice, oh gosh, everybody did this wrong. I better address it in class tomorrow. But so that's not graded based on right or wrong, which means you don't have to try to sit by the smartest person in class so that you can get 100 on that. So as long as you're in class participating on that, and then somewhere down here later, I talk about, again, I'll come to this tomorrow, but I talk about how you are allowed to miss, or like make up within a week. You have to make them up within a week if you do it. And I think I say a maximum of twice, unless there are extenuating circumstances, okay? But if you're out and you say, well, what did I miss? Was there participation? I'm going to say, go watch the video. And on the video, you'll see what I assigned for participation, and you'll see what the directions were, and then you can email me the participation. Also, there is nightly homework. I used to say, when I first started teaching college, because I started off like as a high school teacher, and I used to say, the reason I teach college is so I do not have to check homework, okay? And students did start writing on the SOPI, which is the student opinion of faculty instruction. Students did start writing things like, well, if she had collected the homework, I would have been more inclined to do it. Okay, so I did use student input to say, like, I'm more motivated to do the homework if I know you're gonna look at it. So what I do is the day of the quiz, I take all of the homework that was for that segment and I collect it. But here's the thing, every single nightly homework has an answer key. Usually it's part of the same document, like usually, here's the document that's the homework, the next page is me filling in the whole thing, okay? So I give full credit even if I suspect you copied my answer. For example, if it's problems that actually take a lot of work and you have a list of answers, I obviously know you copied, but that's where I'm like, whatever, right? Like, let's be grown-ups, let's do the work because we need to learn the material, not just do it for me. So I don't even try to him and haw about, well, I think you copied and you didn't really do it. You know, if you turn in your homework and I flip through it and it's all there, you get a 10 out of 10, I think is what I get. I am sort of picky though. I want it in order, labeled, stapled, or if it's a PDF or if you're submitting online, because I'll have a spot where you can either submit online or you can hand it to me in person. I want a single PDF because it's a huge pain for me if people have 10 pictures. Right, and I can click on 10 different pictures. So please put it in one document if you submit online. So the other thing that is part of the participation grade, so we've got those in-class problems, we've got nightly homework, and then we have labs. Okay, so labs are like my idea of, quote, playing with math. Okay, because another thing that I did is, you know, I have 2 children. And I would read the books when they were young about child development. And it talks about as children are playing, they're learning, right? And if you've ever done work, you know, in the elementary school, there's lots of, you know, play-based learning. And I always wonder, how did we go from, okay, children learn best by playing. How did we go to, you know, 18, 19-year-olds learn best by sitting in a hot room, staring at a professor, writing down notes? You know, how do we decide that becomes the best way for people your age to learn, right? It's not. You still need to learn by what I call playing with the math, okay? So the labs are my idea of playing with the math. Most of the labs we do, the majority of them in class together. The one that is currently being assigned and is going to be due the Wednesday after we come back from our long weekend, which you can't beat that schedule. Come back for a week, get a long weekend, right? That's what I love about fall semester. But it's due the Wednesday that we come back, and I'll take you to that. And we're actually going to do the first problem together and then do some extra exercises along with it. But that lab will be the one that's the most independent. Okay, so at this point, I'm going to stop talking about syllabus stuff. Okay, so any questions about it? I'm going to take you to Brightspace next and show you a few things there. Questions so far? Okay, so over in Brightspace, so and this is what's nice about your generation is all of you have been using some sort of online learning system. All right, you probably had Google Classroom, I would suspect. So you're used to this type of thing. You know, the older people, my generation, were a little less used to this kind of thing. What I will tell you about Brightspace. So the entire campus just switched over to Brightspace this year. Okay, it is very different than the old learning platform that we used to use. Okay, so none of us really like it better, and lots of people are griping about how it changed. And the reason that it changed is SUNY, all of SUNY, you know, it's a funny thing. All of SUNY, you know, so these companies make bids, right? And who gets the contract, the higher bidder or the lowest bidder? The lowest bidder, right? And who necessarily has the best product? Not always the lowest bidder, right? So I don't think that this is as good a product as what we were using in the past. But it's a money thing for, you know, all of SUNY is using the same thing. So if you have friends at other colleges, you know, if you have Brightspace questions, your friends at Boston State could answer them for you. They have it also. I know there have been issues though with people, transfer students who already have an account at a different college or, so again, if you have personal problems with Brightspace, I won't get into that now, but I know there's been issues of it defaulting back to other people's old college. But anyway, so we can look at this as the cup half empty or the cup half full. Cup half empty, Brightspace is not as intuitive, it's not as easy to navigate. I don't like it as well. I don't think any professor on campus likes it as well. I don't know how the students feel if you've used other learning systems compared to Brightspace. So we're all not that happy about it. So that's the cup half empty approach. We could go for the cup half full approach and say, well, Sumi, this is obviously a money saving move. Thank you for trying to preserve funds to help keep our tuition costs down. Right? I mean, we could look at it that way. Because if somebody said to me, hey, you want your cost of living raised, well, then we have to switch over to Brightspace. I'd be like, okay, give me my cost of living raise, I'll work with Brightspace, right? If that's where the funds have to come from. Okay, so you're gonna need to be patient with me because I'm still learning Brightspace. The whole campus is trying to learn Brightspace and our CIT department is only so big. So I've really done my best to not bug them and figure out what I can on my own. So things that I want to show you then on Brightspace. So let's see. So modules that I have made. Oh, wait, you go to content, which at least that part is totally obvious. Okay. And your window and my window do look different. So you see, I have a ton of hidden content on the left because I brought in my old course and then I hid all the content. So you can see here under daily lessons and assignments, here's the lab. Actually, what I do like though is it lets me put descriptions with the items. So we're going to actually start with lab 1 today and do the first problem together. So if you want to, if you have your computer and you want to open it up, you can. I actually did make and if you don't have your, if you don't have it open on your laptop, I'm going to be projecting it on the screen. So, it's not totally necessary to, have it open at your individual seat. I have a few paper copies just kind of like left from old years. So if any of you is like, oh gosh, I really want a paper copy. I don't know, people can like, some of you are raising your hands, so. Yeah, why don't I capture you around if you really like pencil paper. Somebody back there wants one. So yeah, I don't have enough to give everybody a paper copy, but some of you would prefer having it printed out right in front of you. But again, so one of the things that I'm going to do, and I don't feel guilty about this because I'm not making you buy a textbook and I'm not making you buy a calculator, I'm going to take a bite out of your printer budget. Okay, so there's a lot of times where I will write, have this printed for class, or sometimes I'll just write print or have access, meaning that, I don't think you have to have it printed, that it's just, it's a list of problems, and as long as you have them in front of you, you can do all the work in your notes. But there's certain documents where you really need to be able to write, like I might have a printout where there's like a bunch of graphs and stuff. So you really need a printout in front of you to be able to do the problems, okay? So if I definitely want you to print it, I'm going to say print this for class tomorrow. Otherwise, I'll say print or have access, okay? So we're going to look at lab 1 in a minute. I also did, so let's say I made a little sub module, okay? So we're going to do a little bit of this today, solving quadratics. We're going to, if I don't talk too long, which I'm running into the danger of. And then, as is the case with many of the prerequisite skills, do you know the difference between, f of x equals 7 versus like f of 7, right? Can you do that? So there's a self quiz on here, and it's the same thing you had with the integers. There was a self quiz. Okay. And if you get everything right on the self quiz, and so down here, I could give you the instructions. If you get everything right on the self quiz, you're done, right? And you understand it. This does need to go with the collected homework, but if all I see on your collected homework is you did one problem with solving a quadratic and this few question self quiz from here, that's good, okay? But if you get things wrong on the self quiz, then you go back and work on the question. So again, the skills that are on tonight's homework are things that we're going to get to if I don't talk too long, which I need to be mindful of because I already feel myself starting to talk too long. But anyway, the last thing that I want to show you here And then we can start actually working on stuff. So I do have, right, so here it is. Both of these handouts, I made one video. So the first part of the video is me going over the quadratics. Okay, then, the second part of the video, so here's where I go through all the problems on it in detail. And then like about 8 minutes in, right, I start going over the next handout. Okay, so that way if you're having trouble. So as I said that, all right, let me turn this off. Okay. So let's see, am I still sharing? Turn that off. Okay, so those will be tonight's homework. And again, I do a lot of work to try to support you on the prerequisite skills. Okay, because you will be unsuccessful in this class without them. Okay, so I put a lot of attention, but that's really where it's your responsibility. Okay, you try to self-quizzing, like, I don't know how to do that. Don't just, well, hopefully she won't have it on a test. Like, that's a very fundamental skill. And if you don't have a handle on it, you're really in danger of not being successful in class. Okay, so here's the lab. Okay, so first question on this. So the directions say, graph them in the standard window. I do want them on a separate piece of paper. So if you print this, sometimes students will have this little tiny graph right next to, and they don't have to be done on graph paper though. We don't want that much detail, but if you had, a separate piece of paper where, each problem got, I don't know, 1.5 inches by 1.5 inches square, or 2 inches by 2 inches square for each graph, that would be perfect, okay? Then there are problems on the back where you're going to answer to the best of your ability. You're going to do everything except for the last question on the back page, okay? Because labs are where we play, okay? And so you're not expected to know everything, okay? So if you look on the back page, you're going to start seeing words, and I hope these words sound familiar, or actually I think some of the questions start down here. Well, we're talking about asymptote lines, domain, range. I hope these words sound familiar. You're going to try to identify. So what I've done is I've taken a whole bunch of types of functions. Lots of them should look familiar. Some of them maybe you spent less time on in high school, like those fractioning ones, right? You probably did less of those than you worked with polynomials. Right, so, could we look at the front? Let's go back and look at the front, and I don't want to give away all the answers here, but, and then again, there's functions that don't fit any category. Like there are a couple trig functions there, but I didn't put a category for trig. And so you're going to try your best on questions 1 through 4. One of the questions here, you should, if you are good at pre-calculus, be able to draw it without a calculator because it's just a shift of our old friend, the standard parabola, right? So we all should know, there should be one of our best friends, right? This parabola, and then we could shift it up and down or move it side to side or make it get bigger faster. We multiply it by a constant. Does anybody see up there which of those functions is just a shift and a shift of that guy? Which function is that? Tell me your name. Brad, what function? D, yeah. And this would also be considered a polynomial function, right? And so you should be able to look there and say, okay, polynomial, I've heard that word before, right? And try to think about, it's hard to see it, but down here we've got x to the 2/3. Is that a polynomial? Right, and then we've got a bunch of, like I said, these fractiony things, okay? So we want to get the general shape, and we also want to determine the range. And for domain, for the most part for domain, we're either going to say all reals or not all reals, right? So the next document, well, actually, no, let's do this first. Let's grab our calculator. So we're going to graph that first function. And you were told to use the standard window. Okay, so maybe I would do that first. So standard window, if you go into window, and then if you just hit zoom 6, okay, so my window's on 0 to 20, some weird Y values, right? So let's go into standard window, zoom, and so you can see number 6 is Z standard, right? The standard window is from -10 to +10 for both the X and the Y axis, okay? And I made sure to choose functions that you can see well in this standard window, right? That show their critical features in the standard window of -10 to +10. Okay, so anyways, we go to our Y equals, make sure you're using parentheses because your calculator does know order of operations. And so if you didn't put the numerator and the denominator in parentheses, your calculator would actually divide first. It would see X divided by 2, or 2 divided by X, and it would do that first. Okay, so numerator and denominators have to go in parentheses. So then we look at the graph. So if you want to have a separate piece of paper, right, and just draw a general sketch of this. And then what we're going to do is we're actually going to analyze this in detail, but you're not going to do that with the rest of the page you graph. Okay, so if you wanted to copy this down on a piece of paper that's going to turn into the lab assignment that you're going to turn in, then go ahead. This is the first problem. But then we're going to take some notes because we're going to really analyze this problem and talk about things like range, domain. We're even going to talk about x-intercepts, y-intercepts. Okay, so we're going to do some analysis that you're not, the rest of the lab, you're just graphing. Okay, you're not doing all the analysis that I'm going to do in a minute here. Yeah, like I said, like 1.5 inches by 1.5 inches. You don't want to draw them too small because we're going to keep coming back to this lab and keep looking at these functions, and this is kind of a springboard for us to get into other topics. Okay, so I am going to, so you keep your calculator out, but I'm actually going to close this window because I copied and pasted this onto another document. So you keep your calculator open. I made a document that I did not share with you. And that's because you're just going to write these notes down. So let's see, this should be Smart Notebook, this one. Right. So first of all, function. You have heard the word function so many times. One of the good things about the recent curriculum, oh, by the way, is it almost 11:20? Not quite, but we have a supplemental instruction leader. I don't know if you've had those in other, well, a lot of you are freshmen, but she's a student, math major, and she's going to hold extra support sessions. She's going to be attending though my 2 o'clock session. She has a class that overlaps with this class, but she can't be in this class, but she's going to pop in a minute and introduce herself. Okay, and then I'll let her talk a little bit about what her role is. But again, when we talk about lots of things for extra supports, the problem with extra supports is you're the one that's got to grab onto them, right? We can't do that for you, but there are lots of extra supports for you. So anyway, the word function. So have some other piece of paper where you're taking down some notes for today. Okay, so the word function, we've all heard the word function before. What does it mean to say like a person is dysfunctional or my computer is malfunctioning? Right? What's a dysfunctional person? Not orderly. Not orderly, or they can't do life chores, right? Or your computer is malfunctioning, which means it's what? Not working. Okay, so the word function, like for something to function, it actually means to work, to do a job, right? So one of the ways I could define function is it states a job, okay? So, this is a function, okay? And it states that its job is to take the input, right, that goes right here, and the function f says take the input squared, okay? And this notation, and we should all be comfortable with the idea that y and f of x can be used interchangeably. Okay, because y is where the output goes, right? Because again, functions, I could show a list of ordered pairs. That's if I let my domain only be whole numbers though, right? But I could say, okay, these ordered pairs define a function, right? The first number is the input, the second number is the output, right? And I could look at this graph and say, well, this defines a function, right? If I have this input at 3, then this output is called f of 3, right? F of 3 is a y value, right? And so y is equal to f of 3, which is 9, okay? And so this notation says, I did a job on that input. That's what the f means. I did the job on this input. One of my favorite analogies for a function is a vending machine, okay? Because you guys learn different things. Like, throw out some things you know about functions, like definition-wise, or just how to tell us a graph's a function. What are some things you learned about function? You remember? Kind of tested, always have to pass. What was that?
The line test.
The vertical line test. Nobody really knows what that means. I think they just know fails the vertical line test on function, right? Do you remember other things about input? Like, can one input have more than one output, or can one output have more than one input? You remember that being a big thing in high school? I like to think of a vending machine. Okay, like if you went out there and looked at a vending machine in the out in that hallway, there's like 3 rows of water and like 3 rows of Coke. Okay, a vending machine is a function because when I type in, my input is something along the lines of A14, and then my output might be a bottle of Coke. Okay, so a vending machine is a function. Now I can get Coke by pressing A14, and there's probably another row of Coke right next to it, and I can still get a Coca-Cola pressing something different, right? So this different inputs can give us the same output. Okay, that can happen. But if I'm in the mood for M&Ms, right, and I go up to my vending machine and I type in B5, and I'm expecting a package of peanut M&Ms, right? I don't want to have to wonder if I press B5, am I going to get M&Ms, or am I going to get Skittles, or or am I going to just like get some Pop-Tarts? I mean, they have all sorts of things, right? So this would not be a function, right? If I type in B5, I want it to only give me the output I'm supposed to get. I want my peanut M&Ms, okay? So my favorite way of describing a function is a vending machine, right? Because again, common sense, right? Like I said, lots of math really can be common sense when we look at it that way. So definition of a function that I want you to write down, the simplest definition of a function that I could possibly give you is that, there's an input and an output. Where did I put my notes for today? I mean, I know what here it is. Okay, so let's see. I was just looking at what I have written down. I mean, there's lots of different ways I can define this. So I have a rule which assigns or maps, right? That's another word we could use, that 1 maps to 1, 2 maps to 4, 3 maps to 9 in that function. That assigns or maps an input to an output. And we can call the output an image. Okay. And so I like the idea of example vending machine, right? But the simple definition is put a value in, get a value out. All right, it's an input-output machine. Okay, and actually my teacher, well, see, now this was, I mean, I'm old and he was old when I had him. But he's probably thinking of some sort of machine from like the 1930s, but he used to always draw the functions as a machine. And he would say like, this is where you put the value in. So if this was the x squared function, and then he would always talk about put the value in, turn the handle, and get the value out. And that's how he always described a function machine. Okay, so that was something that really helped me to connect. And I liked the way that he would do the thing where if there were multiple outputs for the same input, like if 4 could go to, if 4 went to, 7, and 4 went to 8, this would not be a function. And he would like draw smoke, like, oh, well, you get smoke coming out of the machine like that. That messes the machine all up and there's smoke coming out of it. And that's what helped me connect with the definition of a function. So we can't have the word function without the word domain and range then. So what are the possible inputs and outputs? So the simplest thing I can say about domain is that it's input, right? Input, which is on a graph, our X, okay? But on this lab, you're going to be asked to determine the range and domain of each function, or domain and range. Domain is easy, range will be much harder, okay? So for domain, we're going to get into a different type of function, which doesn't quite follow this rule, but we're looking at what's called algebraic functions. For us, well, actually, wait, let's do this first before I give you the definition. Here's our graph, right? And so part of why I like having it on here is, and you guys have the more modern, probably none of you have the calculator that shows a line there. All of you, does all of your screens look like mine, or do any of you have the screen where it's like actually a line? It looks like it's connecting them. That was like an older, the updated ones don't do that anymore. The one that would show the line, that was the calculator not being smart enough and thinking that this last point they plotted here was supposed to connect to that one. They put a line. Students would sometimes think that vertical line was part of the function. Okay, but right there we have what's called a vertical asymptote line at -2. So different ways we can determine the range. I encourage you to go to your calculator and go to table. Actually, maybe I should, I mean, I think you guys all know how to use your calculator, but if we went to table and went to table set, see my table's on some weird thing. So should be a key for table set, right? And let's start our table at say 0 and then change it, table change by 1. Okay, and so then we can look at a table of values. And so that's what I have. So if you're looking at that on your screen, I should see what I'm still screen sharing for the people that might be on Zoom. All right, I think, hang on, I'm gonna go stop share again, just to make sure I'm sharing what I want to be sharing with anyone who's on Zoom. I wanted this. Okay, so anyways, I copied and pasted this table of values into my document. Okay, so we can tell that -2 is not part of the domain, right? Because if I get an error for output, right, a domain, to be part of the domain, the input has to have a certain output. So -2 is not part of the input. How could you look at the equation you just graphed and know that there would be a problem at -2? What is it in the equation? The denominator, right? You look at the denominator, and what are we not allowed to have in a denominator? 0. Okay, so can't have a 0 in the denominator. And so all of our, what I could call fractiony, wait, no, I want my text box back. So we have these fractiony functions, and so they have denominators which cannot equal 0. Okay, so we're always going to have to recognize that when when we're determining a domain that the denominator can't be 0. So domain, let's say this about it. What is with, hang on, my text boxes move here. Okay, now it's huge, hang on. Okay, we can input any value that does not give us a 0 in the denominator. Or, so we do have a function on there, letter I, which is a radical. What am I not allowed to have under a radical? Negative. Let me just specify though, that's an even root. We actually can take odd roots of negatives, but if we have an even root, so just a square root, we can't have a negative. So we can't get a 0 in the denominator or a negative under the radical. Okay, so that's what we're going to be looking at to determine domain. Now, how do I want you to write the domain? Okay, so if we came down to this picture, and you can write this right beside it. Okay, so in order to write the domain, I'm just going to put a D for domain. Okay, there are two different ways you can do this. All right, a lot of you probably would just write x cannot equal -2, right? Because that's the kind of thing you did in high school. Let's try to step it up a little bit though and use different types of notation. We have, so different types of notation. We have set builder notation and we have interval notation. Set builder notation. And then we have interval notation. Right? So instead of just writing x cannot be -2, to write this properly in set builder notation, you make this squiggle, this squiggly thing. Okay, it's actually this key. Oh, wait, it's this key on the calculator, right? So you would write that squiggle, the set of all x such that, so then you put a straight line, I can type that, x, and now I have to go to my crayon to do not equals, x does not equal -2, and then you end with a bracket. Right, so that's called set builder notation. So that's a little bit more formal than just saying x cannot equal 2, right? Now interval notation, maybe give you a second to catch up. Think about a number line. Oh, here she is, Mia. So come on in, say your thing, and then I did remember to tell them you were coming.
So my name is Mia. I'm your semester. I'm going to set out an really about what time that's for you guys. If you're unfamiliar with what it is, it's basically just a free tutoring session. So if you guys need help, I'll be available 4 hours a week. You come in and ask the questions you need. Probably also be holding quiz reviews and exams.
So if you have 4 hours a week that they're paying you for, I think that's up. I think last semester was 3. So, so what she'll do though is part of her job is not just to like answer your questions. Part of her job is to take, so like I said, she's going to sit in on the 2 o'clock class, so she'll know exactly what we're doing. Part of her job is to make some extra examples and then just go over extra examples with you. Okay, but then she could also ask questions about, you know, if you have questions from your homework or things we're doing in class, you know, you can ask her questions. So she'll send that doodle poll to see when people are mostly available. Awesome. All right, thank you, Mia. All right, so back to this set build or interval notation. So think about a number line. Okay, if I drew a number line, right, where every possible number was on there. Okay, and here's -2. Okay, I cannot, so you did some of this sort of thing in high school where you would leave an open circle here and then you might shade in both directions to show, you know, those are the values you can have. In order to use interval notation, you go like this. We do this, what's called an open bracket, which is one of these guys. right? If you're typing, it's one of these guys. So open bracket, and then you put negative infinity, comma, and we can get all the way up to -2. Now, how close to -2 can we get? I mean, do we stop at like -1? No, because are there values between -1 and -2? How many values are between -1 and -2? Infinity, right? There's an infinite number of values just between -1 and -2. So by using this, what's called this open bracket, that says I can get all the way up to -2, but I can't equal -2. And then we put this U stands for union. So we go union and then -2, comma, all the way to infinity. Okay, so this is known as interval notation, and I encourage you to practice using both notations. Some of the ones that you're going to draw, for example, if you get a, if you draw your y equals x cubed, right? Y equals x cubed, the domain is just all reals, right? And so a lot of times when we want to write that, sometimes you kind of make the R fancy, but you would just write that for domain, right? So you could write D : and then just like a fancy R, okay? Now, range is harder to determine, okay? So if I looked at this and wanted to say, well, first of all, so if we look here, give me a value that is not part of the range. The range is outputs. Range is y. So what do you say, Brad? -3. -3. So if I go down here, so possible y values, if I go down here where y is -3, and let me I'll select red because we can't do it. So look at here. Oh, straight, come on, be straight. Oh, that's supposed to be straight. Oh, there we go, that's better. But y equals -3, right? So see here, there's no x that will give me this output. Now, if I ask you, is +3 in the range, right? And I went to +3, so up 1, 2, 3, and I went like this, and I drew a value at y equals +3, I would say yes, y equals +3 is in the range because there's an input, and the input is whatever x value I just landed that black vertical line onto. There are two inputs, and we know that's okay because there's two things on the vending machine that will both give me code. So this is fine. There are two values of x that will output +3 in my function, right? So +3 is part of the domain. So if we want to be really picky, we could find this maximum, we could find this minimum. But we're going to go ahead and just say for this function that the domain is not all reals. Okay, so when we write, or I'm sorry, I said domain, I meant range. Range, okay, so I'm going to do that. Range is not all real numbers. So if most of your answers for range are either all reals or not all reals, I'm pretty happy with that. Okay, so something that does have a range of all reals. Actually, if I drew it over here, we just looked at y equals x cubed. Right, so y equals x cubed. Right, and it does this. And any y value I went to and went across, some x gives me that y. Okay, which makes, if I'm down here, right, this is a y value, this value of x right here, whatever that x is, gives me that y. So it's part of that y value is part of the range. So let's say this is up in the vocabulary. So let's say, we'll pop back up here. for range that, let me minimize here. If I can find an X value that will output a certain Y value, then that Y value is part of the range. Okay, so we're going to look at intercepts in a minute. Let me just pull up one other example. Let me show you. So let's see, X, Y, and then if I drew, starts at 0, 0, and that's an okay picture of it. So that's a parent function. I hope your pre-calculus and algebra 2 teachers made you learn parent functions, right? Like y equals x cubed is a parent function, y equals x squared. Do you know what parent function that is? That I just drew, so it can't have any negative inputs. Right, so the domain, and let me show you how to write domain for this one. If we were using set builder, set builder notation would be, like I said, those brackety things. So for domain, set builder, you would say the set of all x such that x is greater than or equal to 0, because it can equal 0. 0 is an input. If I input 0, I output 0. Okay. If I were using interval notation, I actually use, these are called hard brackets. So they're different. That's a different symbol than we used the last time. Hard brackets mean that I can equal the value 0. Okay, these are called open brackets like this. This means I can get really, really close to that value of -2, but I don't touch -2. This means I actually can touch 0. And you always use an open bracket on the infinity end because you can never get to infinity. Okay, I think sometimes students think that numbers go on for a really long time and then all of a sudden there's a sideways 8 and numbers end, right? Infinity is a concept, not a number, right? So the concept of infinity is if you, anytime you think you're at the largest number you could possibly ever find, add 1 to it. Then if you say, well, that's the largest number, no, add 1 to it, right? So numbers, you know, and it's hard for our brains to even comprehend infinity. Okay, so this is the domain. So no one recognizes this parent function. There we go, square root of x, okay? Okay, so this is square root of x. And so again, the range of this function, actually the range and the domain end up being identical, right? Because I can only input positives. So this would be both domain and range, right? Would be these answers. Okay, except if it's range though, when I'm doing range, I'd want to say the set of all y such that y is greater than or equal to 0. Okay, so like I said, I encourage you to practice with this. And on tomorrow night's homework, I have actually a short little video of like helping you with this notation because we're going to look a little bit more at this on Wednesday. So anyway, let's talk about, I got 10 minutes. See, I talked too much in the beginning. I knew I was. Let's kind of quickly here look at this table of values. We want to define y-intercept and x-intercept. Which one is staring me in the face? A y-intercept or an x-intercept when I look at that table of values? The y-intercept, right? Because the y-intercept occurs when x is there, right? It's the opposite. So let's say this. So y-intercept, actually, I guess I don't need to panic. I only have a couple more things I want to do. We have 10 minutes, 9 minutes. Okay, so the y-intercept occurs when x equals 0. Okay, the x-intercept, which if we look at our function, and we can see this on our function. If I went back to the graph and circled these points, this occurs when y equals 0. There's another name for x-intercepts. Do you know any other words that we would call them? Roots, yes, roots or solutions, or we would just say zeros of the function, right? Zeros of the function. There are a subtle difference between, because graphs have, let's see, equations have solutions and zeros, graphs have roots and intercepts. Okay, so there's a slight difference between whether we mean the equation or the graph. Now, look at this. Now, this kind of messes things up here because we have an asymptote in the middle. But look at this table of values. Can you tell me between what values of x would there be a y-intercept? And how you would know? So think about that. Maybe I'll ask you to tell the person next to you if you can think of it. So if you don't know, that's fine. So between what values of x would there be a y? I'm sorry, I'm misspeaking. I want an x-intercept. Between what values of x is there an x-intercept? Okay, so tell the person next to you how you know. I love hearing math talk. It's wonderful to hear students talking about math. So we can see right here, here's the point 0, -1. We knew that that was a y-intercept because x was 0. And then let me change colors here. So you knew there had to be one when the sign changed, right? The sign in that table went from negative to positive, right? We can't go from negative to positive if the function's continuous without passing through 0. That's why I said this messes us up a little bit. All right, but anyway, it's really important then for us to understand the difference between f of, so we're going to look at f of 4 versus when does f of x equal 4? Okay, algebraically, one of these is very easy. Okay, so we're going to go to the graph for a minute, and I should have just enough time to finish what I hope to finish. If I look at this graph, okay, which I now have covered, let's see what I can erase. I think I can, it won't let me erase the lines I drew. I don't know how to get those to go away, but anyways, f of 4. So one of those means go to 4, 1, 2, 3, 4. So here's 4 and go up to the function and find the y value, right? That's the meaning of one of those. The other one means go to 4, 1, 2, 3, 4. Go to 4, go across, and then look down. Okay, so which is which, purple or green? Which one is letting us find f of 4? And which one is letting us find f of x equals 4? So purple or green? Okay, what do you think? F of 4. No, f of 4 is the green, right? Because this is the x, right? That's the x value. So this says go to x is 4, find the y. Okay, whereas f of x equals 4, that says go to the y, find the x's that give me this output of 4. Okay, now algebraically, which one of these is easy algebraically? So we have this function that's f of x equals x squared. So which one is going to be an easy computation? The one on the left or the one on the right? I'm trying to write too fast. One on the right, okay? So the one on the right just says everywhere you see an x, put a 4. All right, and we can compute very quickly, which we don't really have time for. Now, the one on the left says put a 4 in place of the f of x. Okay, now how am I going to do this? Right, that doesn't look like a very fun equation to solve. All right, so how am I going to solve that equation? All right, so suggestions. Perfect. Or you could think about cross multiply. Remember in middle school when you put this over 1 and you could cross multiply? But yes, that's exactly it. Multiply both sides by x plus 2. I'm going to go ahead and distribute all in one step. So you would do 4x plus 8 equals x squared minus 2. Okay, so this is called a quadratic equation that I just got to. Do I want to try to get the x's on one side and the whole numbers on the other? No, that's what we do in linear equations, right? Where there's only the x to the first, right? So quadratic equations, how do I solve those? I take everything and bring it to one side, right? So everything comes to one side. So again, if this is a little rusty for you, tonight's review is on solving quadratic equations. So I like to have x squared be positive. Okay, so I am going to choose to bring everything to the right because I always want my first term to be positive because why have a negative if you can avoid it? So I'm going to subtract 4x from both sides. I'm going to subtract 8. So remember, -2 minus 8, it is not 6. That's why I gave you that little practice handout. -2 minus 8 is -10. Then what do we do? Like solve a quadratic, we do this business if we can. Right? Can we do that? Unfortunately, no. I don't know any factors of 10, 2 and 5. That's not going to give me 4. Okay, so then what? It's not factorable, so then what? Quadratic formula. So why don't we do this? There's only 1 minute left, and I always try to leave a minute or two because people will come up to me and ask me individual questions. Let's open with this tomorrow. So first thing tomorrow, we will use the quadratic formula. So sometimes I post a homework, and the homework is on using the quadratic formula and solving these. If you wait a night then to do that homework until we review it in class, then I tend to get overambitious when I think what we're going to get through in class. So, all right. I will see you guys Wednesday then.